Hello, today we are going to discuss about 8086 microprocessor and register organization of 8086. So 8086 is the one of the microprocessor. A microprocessor is a device which can perform a arithmetic operation, also a logical operation. So and it is stored in the program memory and it produces the result as a number. So there are a number of microprocessor available, like example 8086 microprocessor, 8085 microprocessor. So like Intel Pentium, there are so many microprocessors. So this is one of the first basic microprocessor we are going to discuss. So what is the difference between a microprocessor and a microcomputer with the microcontroller? So microcomputer is a computer with a microprocessor as its CPU, and it includes a memory and input output, where microprocessor is a silicon chip which includes arithmetic logical unit and instruction decoder and circuit. So it has been connected externally, where a microcontroller everything in a single chip. It can be decoded with single IC like memory and an input output, ALU, everything inbuilt in a single chip. So that is called a microcontroller. So example we can see 8051 and PIC microcontroller. So these are the example. So if you are seeing the basic architecture of microprocessor, which has the input unit, it will process the input, and by using a ALU to perform the arithmetic operation or a logical operation, and it produces the output, and it meanwhile it stores the output to the memory unit. So what is the organization of the microprocessor? So we can see in any organization of the microprocessor which has the ALU and register unit and control unit. So ALU stands for arithmetic and logical unit. It performs arithmetic operation like addition, subtraction, multiplication, division, where logical is XOR, AND, OR, NOR operation, and for that we require some register to store data. So 8086, since a 16-bit microprocessor, it stores the 16-bit data. It will store, and to control the data between the ALU and the memory, so we require control signals like a read, write signal. So by using the read and write signal, so the data has been controlled. So and the microprocessor has been connected with the input output unit and memory unit. So there are two types of memory. One is a program memory and it's a data memory. So that has been divided into RAM memory and ROM memory. So if you are seeing the functional block diagram of 8086, so it has the ALU, so it is a computation unit perform the arithmetic and logical operation. So and it has the register unit, and it is the internal memory organization, and then flag register. So in the flag register, if for perform arithmetic operation, in case the excess bit if you are getting like a carry flag, or if you are getting signed operation, so then the carry sign flag will set. So depends on the output of the arithmetic operation, the flag register will give the indication to the microprocessor. And register is as I discussed already, it is the internal storage of the data to store the 16-bit data. And we have timing and control unit. So the timing and control unit, to give the read signal, write signal, and the clock signal, how many number of cycle it has to take, so those informations has been given by the timing and control unit. So the instruction decoder, so it will decode the inputs, the program which you are writing, it has been converted to opcode. So those opcode has been decoded in the decoding unit. With respect to the timing and control unit, this has been controlled. And a program counter and instruction pointer, it generate the program, it has been fetched to the next memory location. So for example, the processor having 4 lines of program, so the processor has to execute which line, so that information has been given by the program counter. So now we are going to see the Intel 8086, which has been developed by the Intel in the year of 1978. This is a third generation microprocessor, and it has been designed with HMOS technology, and it is a 40-pin dual in package. So there are different version of 8086 available, like 5 MHz, 8 MHz, 4 MHz, 10 MHz. So depends on the version of the 8086, this will be vary. So and what is the features of 8086? So it is a 16-bit microprocessor. It is ALU, Intel register, work with the 16-bit binary words, and it is 16-bit data bus, and it has a 20-bit address line. From the address line, we can able to find out how much number of memory is required, like a 2 power n. So 2 power n, that n indicates that number of address lines. The number of address line is equal to 2 power 20, that gives the 1 MB memory location. And in 8086, there is a special features called, it is a segmented memory. The 1 MB memory has been divided into 16 logical segments. In each logical segments we have 64 KB of segmented memory is available. And the main features of 8086, if we consider, it can act as a minimum mode operation, also a maximum mode operation. A minimum mode means it acts as a single processor, where maximum mode it acts as a multiple processor, and it requires the 5 voltage of supply As we discussed, it has a 40 pin dual IC. Here if you are talking about the register organization of the 8086, which has a 4 general purpose registers are available, like AX, BX, CX, DX. So AX is act as a accumulator, BX will act as a base register, also a general purpose register, CX will act as a general purpose register, also a counter register. So if I want to create some delay, so I want to create a delay for 5 milliseconds, then I can give the counter value to the CX. So that's a CX is act as a counter register, and DX is act as a implicit operand. Example, if I'm adding if I'm multiplying a two 16-bit number, by default if I'm multiplying a two 16-bit number, I will get 32-bit output. So one 16-bit will store it in the EX register, the another 16-bit by default it will store it in the DX register. So here the DX will act as a implicit operand, and we have 4 segment registers. Code segment, it will store the code, where stack segment, it will store the stack memory location data. Data segments also store the input data which you are storing. So apart from that, if it is 64 KB is excess, then the excess data will store it in the extra segment. The flag register, we have 16-bit flag register which has a carry flag, overflow flag, sign flag, zero flag, and direction flag, trap flag. So these flag registers are used to give the indication about that arithmetic operation or logical operation. So in case if any interrupt is occur, the interrupt flag will set to 1. In case when performing arithmetic operation, addition operation, if you are getting a carry, then the carry flag will set to 1. So those indication has been given by the flag. And a pointer and index register, stack pointer, base pointer, source index, destination index, index pointer. So this is for to indexing the register source register, it may be our destination register. So it always points out the memory location. So when I'm performing a stack operation, so the SI and DI will be using for the programming. And what is a flag with a it's a flip flop? Actually, it's a flip flop. It indicates some condition to control a microprocessor. So these are the 16-bit flag register, which has it has been classified into two. One is called conditional flag, and one is called control flag. So conditional flag in the sense, if the condition is occurred, then this flag is set to 1. Example, CF is nothing but carry flag, parity flag, auxiliary carry flag, zero flag, sign flag, overflow flag. So where the control flag is nothing but trap flag, interrupt flag, direction flag. So in the condition flag, the carry flag, if it is a MSB bit, MSB bit is equal to 17th bit, then the carry flag will set to 1. So if it is the parity flag, if we check whether the odd number of ones or even number of ones is occur, then the auxiliary carry flag, if you are getting a nibble greater than the carry getting in the nibble bit, then you will get a auxiliary carry flag will set to 1. So the zero flag will set to 1 when the odd number of zeros or the even number of zeros. So depends on the operation, the zero flag will set to 1. So this is a flag register. So the flag is set the carry or borrow after an integer arithmetic operation. So the D4th to D7th bit, the flag will set to 1, that is for auxiliary carry, and zero flag if the result of arithmetic or logical operation is 0, else it will be reset. So sign flag, if the sign magnitude format, the sign number indicates the MS bit. If the result operation is negative, then the sign flag will set to 1. So overflow flag will occur when the sign numbers are added or subtracted, and OF indicates the result has exceeded the capacity machine, that is the result out of the range. And the control flag is nothing but trap flag. So it is used as a single step, whether the processor is going for the single step execution or a multiple step execution. So that information has been given by the trap flag. So the interrupt flag will be enabled or disabled if it is an interrupt is occurred, that information given by the INTR pin in 8086. If the interrupt is occurred, then the interrupt flag will be set to 1. So that is the interrupt flag. So a direction flag is used for string operation. So string in the sense, if I have some set of character, so that character has been chosen, and if you are performing a string operation, then the direction flag will be set to 1. So and these are the general purpose register which has been paired with AX, PX, CX and DX, and base pointer and the instruction pointer. So it will be stored into the memory, and the IP has a hold always 16 bit. So this 16 bit has been stored with the memory, and we have calculating the physical address. So how we are calculating a physical address? So segmented address into 10 plus the offset address. So offset address has been held by the instruction pointer. So from the instruction pointer or base pointer, we can find out the offset address. Then from the segment register we can able to collect the segment address. So the segment address into 10 plus offset address, we will get the physical address, otherwise called as effective address, for a 20 bit. So similarly the stack pointer, so the stack pointer it will store with the stack segment plus the stack pointer. So from the stack segment append 10, that is a multiply by 10 stack segment plus the from the stack pointer we will get the offset address of the stack pointer. So that will be added, we'll be getting a physical address for the stack pointer. So the segment signature, so we have 1 MB memory. This 1 MB memory I will divide it into 16 logical segment. Each logical segment has the memory of 64 KB. Each 64 KB has occupied the 4 segment register. One is a code segment, data segment, extra segment, stack segment. So that is the use of the segment register. So these are the references for that. Thank you.